Good afternoon, everyone. I hope I am audible. Good afternoon. Muthukumar sir, am I audible? Is Prabhu sir is joined? Good afternoon. Am I audible?
Yes, sir, audible.
Sir, Muthukumar sir, is Pramod sir, Prabhu sir is there in the group, joined? Muthukumar sir, kindly unmute yourself and let us know that Prabhu is there, the resource person. And I request Vardhaman faculty to come to the PDP to room number 301.
Hello, sir. Good afternoon. This is Prabhu, IoT faculty, and Muthukuman sir is available there, but he said that proceed for the class today.
Yes, sir. Kindly, you can. I welcome you, sir. You can start the session for the day, sir. Thank you.
Yes, sir. Thank you. So I think all the students are ready for today's class. As we have discussed in the yesterday's topics, we have covered all the basics that we need to have and learn and know to implement these practical sessions uh, according to our syllabus copy. So in our syllabus copy, we have included environmental monitoring and load control, GPS modules, GSM modules, and along with the protest simulations, and which includes the practical implementation. So in the yesterday's class also we have seen real-time equipments, how ESP32 and some of the hardware looks like GPS module and ultrasonic sensor. We have seen some of them. So in today's class, we are going to implement DHT sensor, that is nothing but digital humidity and temperature sensor, which will read the environmental temperature and humidity data, and where we'll send that data to our IoT platform. So before going to directly to the topic, I would like to introduce you about basics that we need to, some more basics that we need to know about this practical session. So first of all, we need the components regarding this part is ESP32 and digital event sensors. I will just draw a block diagram so that students can learn easily. So I'll just draw a block diagram regarding that.
Sir, kindly share your screen. Yes, your screen is not visible, sir.
Yes. Oh, yes. I'm just sharing the screen. So I've just started screen sharing. So anyone confirm that whether we are getting the screen share or not?
Yes,
My
sir.
screen is visible. Yes, thank. So So the today's topic is about environmental monitoring. So in that topic, we are going to read digital humidity and temperature sensor data by using ESP32, and we are going to send that data to one of the IoT platform. So first of all, I will like to tell you about what the IoT platforms we have in the market and currently utilizing in the industrial sectors and regular learners. So first of all, I will just draw a block diagram regarding this. I will just take a ESP32 and I will connect a DHT sensor to it. I think this screen is visible to all. If anyone having any issue, let me know once. So I will consider this as a ESP32, and this will send the data to our cloud. So in our case, I'm going to introduce a new cloud, that is a Fire-based database, which is developed by Google. So which is very easy to learn as a beginner. So that's why I have preferred this cloud platform. So I will just read the DHT sensor data by using ESP32. So first we have to learn what is DHT sensor, and regarding ESP32 we have seen yesterday. We'll implement the practical today, and the third component is IoT cloud. So we'll learn these two things and we'll directly implement the our task. So DHT11 sensor. So this sensor is for reading temperature and humidity by using our microcontroller. Okay, digital humidity and temperature sensor. Means this one sensor can give the two types of sensor data, like one is a humidity and another one is a temperature. So this sensor will include two sensors data combined. And in yesterday's class, we have discussed digital and analog sensors types. So this sensor comes under the digital sensor because in the name itself, we can say it is a digital sensor. Hence, it is giving the data as a zeros and ones. So that data can be read by any microcontroller directly without any conversion. So if in case the data is in the form of analog, so we have to convert that into digital format by using ADC converters that we have seen yesterday. So this sensor will give the directly the binary data. So no need of any ADC here. So in this case, we have to connect the sensor pin to the any of the digital pin. So I will just show you the circuit diagram of that ESP32 and DH11 sensor connection, and I will just proceed so that you can get a clear clarity what we are doing. So this is the block diagram. I'll just show you the circuit diagram as well. Give me 1 second. So in meanwhile, if you are having any doubts, you can let me know, because in your point of view, I don't know which type of which kind of doubts you are getting. So you have to clear your own doubts. So this is the circuit diagram regarding the connections we can call, or else we can call it as a schematic. So here the ESP32 is connected with a DHT sensor. It is having three pinouts, that is a signal and V in and ground. So every sensor or every module will have three common pins. Okay. So if we are using any sensor, it will have three common pins, that is two power supply pins, one is a signal pin. So here the signal pin will give the output and it has to be read by the ESP32. So here we have connected 3.3 volts. So as DHT sensor works on the 3.3 to 5 volts voltage level. So before going to directly interface any sensor with the ESP32, in the yesterday's class, I have told you one important thing. So that is nothing but we have to check the specifications of that sensor. Okay, so here the ESP32 specifications we have seen yesterday. Okay, ESP32 specifications. What are the ESP32 specifications? What is the input voltage and operating voltage of ESP32? Student has to respond. Anyone remembered? We have seen, we have taken long session for these specifications only regarding ESP32, Node MCU, I mean ESP266. All these kind of boards we have seen. 3.3 volts and 5 volts. So 5 volts is the input voltage and 3.3 volts is the operating voltage, right? So here we have to know the operating voltage of this sensor as well. Okay, so in a sense, some sensor will have operating voltage and input voltage, but this sensor only have the input voltage, that is nothing but the 3.3 to 5 volts. Okay, because so here we can see this three-terminal IC here. So if you can observe this IC on the ESP32, which I am marking on the screen. So this is nothing but the 3.3 volts voltage regulator. So when you give 5 volts from here V in pin, so this is a V in pin where you can give the 5 volts input for the ESP32. Okay, so other than this pin, you cannot connect any input power supply. Okay, you can have to connect V in at the, I mean 5 volts at the V in pin only. Okay, so to know these kind of things, you have to go through the data specifications of this ESP32 module. Okay, so and GPIO as well, as you have seen yesterday's class. So here VIN is nothing but input power supply where you can give 5 volt supply. So if you give 5 volt supply to this VIN pin, this will step down the voltage to 3.3 volts by using this 3.3 volts regulator. Okay, so this is nothing but the AM3117 voltage regulator, so which will step down the DC to DC 5 volts to 3.3. Okay, it's a fixed voltage, it's not a variable voltage. It will directly step down to 3.3 and gives that 3.3 voltage to entire chip. Okay, so this is our main chip and this is a total supporting electronics. And this IC that you are seeing here on the screen is it's a serial debugger. Okay, so every microcontroller will comes with its own serial debugger. If you take any microcontroller, I will show you one more microcontroller, for example. So here I will search for ESP8266. So every board comes with its own serial debugger. Okay, we can call it as a serial debugger IC. So without serial debugger IC, no board can upload the code directly by using our PC. If you don't have a serial debugger IC on the board itself, you have to purchase externally. Okay, so most of the boards that you have in the market will comes up with the its own programmable IC. Okay, on the screen I'm showing a board image of ESP8266. So this board also has the same kind of IC which will represent the serial debugger. Okay, so serial debugger is nothing but it's a mediator between the our PC and the our main chip. Okay, so this is our main chip which will have name of the chip and versions. So this is the main chip, and the main chip will need a programmable driver IC to upload the code of to act as a mediator between our PC and the our microcontroller. Okay, so when you upload code through this micro USB cable, this will convert our total code into binary language, and that binary language will be uploaded to this ESP32. Okay, I mean the the software itself upload the binary language, but it will act as a our mediator between the chip and the our PC, which is like a UART communication. Yesterday we have seen UART communication, right? So in the same way, UART communication will be used in between these two communications, like between PC and our microcontroller. Okay. So in case of our Bluetooth, we have seen Bluetooth Bluetooth mouse and keypad. So in the same way, the Bluetooth in that Bluetooth communication also, UART communication has been using. Okay. So I'm just telling a real-time example to understand clearly. So this is a schematic. We have connected 3.3 and ground and then D2. So to know specifications of this DHT sensor, you can just go to data sheet of the DHT sensor by searching in the internet. So DHT11 specifications. I will just search for the specifications. So every manufacturer of that module, they will release the data sheet of the particular module. So every manufacturer release the module along with the data sheet. Okay, without data sheet, no one will release their module. Okay, so because without data sheet, no one can interface. So no one will purchase that module as well. So in that case, they will provide the data sheet as well. So this is the data sheet image and pinout here, ground, data, and VCC. So regarding VCC, we have to go to the data here. So here the VCC is from 3.5 to 5.5, and in some sensors it is 3.3 to 5 volts. So in our case, my sensor will work on a 3.3 to 5 volts. So it will the operating current of this sensor is 0.3 milliamps, and that's it. This is a total specifications of this sensor, and it can measure the temperature in range of 0 to 50 centigrade. And we have different types of sensors based on the range. Okay, so in case if you want to measure the minus degree Celsius, so in that case you have to prefer another type of sensor. So I will tell you after completion of this task, I will tell you what are the other sensors we can interface to get more accurate values and higher range of values. I will tell you after the completion of task. So, so that's it. And this is about specifications of this sensor. So we can proceed with the 3.3 volts connection, or else you can give 5 volts external power supply as well. So what we are doing here is we are have taken DHT11 sensor, and we are yes. So we have taken DHT11 sensor, we have connected it to ESP32, and we are going to send that data to Firebase. Okay, so now we have completed with hardware connections. Okay, so they have followed this schematic and have connected already the ESP32 and DHT11 sensor. So after completion of explanation, I will show you the practical video of the output. Okay, so now we have set it up with the hardware. So now we have to proceed to the software part. So in software part, we have to have the cloud here. Okay, so we have to set up a cloud platform to receive the data of ESP32, and as well as we have to go through the coding part of this ESP32. Okay, so to code ESP32 or whatever else microcontroller, we have different types of platforms out there in the market. So we'll list out those IDEs. IDE is nothing but integrated development environment. Okay, so every microcontroller will have its own integrated development environment for that particular microcontroller, and that IDE only we have to use to program that code, and we have to learn that code as well. Okay, so regarding Arduino, I think some of you, most of you know about this Arduino C language. Anyone of you know? Raise your hands. So if I get correct inputs, I can know to how much extent I have to explain. Anyone know C language? Yes, totally. There are 36, 30, near to 30 participants are there. Yes. So I think all of you from BTech only. So previously in inter or BTech earlier classes, you might introduce it to C language, but this Arduino C language is quite different to those C languages because it will have its own compiler. It will customize the C language into some libraries so that the language would look like a simple English language like we speak with other communication part. So I will tell you, I will explain you. Majority of the Arduino functions are already defined in the Arduino IDE. So I have sorry, in the yesterday's class also I have given a link to download the Arduino IDE, and I have told to keep it downloaded so that you can know what are the options are there in the software. So this is the IDE that we are going to use for our ESP32 programming. Okay, so at the end of the class, I will tell you what are the IDEs that we can use for microcontroller programming. And this is one of the programming platform which will supports majority of the microcontrollers like Raspberry Pi, Pico, Arduino, ESP32, ESP8266, STM32. Most of the boards will be compatible with this Arduino IDE to program. So that's why I have preferred this platform to program our ESP32 as well. As a beginner also, it is very easy to learn this coding platform. Okay, so I will just explain you about basic syntax regarding this Arduino IDE so that we can proceed with the coding part of the this ESP32 environmental monitoring task. Okay, so yes. So this is the PDF I will share with you guys. And in regarding yesterday's class also, I think I have shared you in the groups regarding that 80 commands and some of the embedded boards I have shared you in the PDFs. So this is the one more PDF I will share after the class. So in this PDF, you can observe that some commands and their definitions are there. So I will tell you the definitions of these commands and functions and to how to use these functions in our real-time practical sessions. I will tell you. Okay, so the first one and important one is pin mode. Okay, so this pin mode command is nothing but to define the mode of the pin. Okay, as we can see here in ESP32, we have a lot of pins here, but no pin has defined whether it is input or output. Okay, so the microcontroller will have a pin GPIO, nothing but general purpose input and output, input or output. So you can define it whether you can either define it as a input or output. Only two options are there. Okay, so that's why we have to let know the microcontroller whether we are using it as an input or output. Okay, in our case we are using D2. So microcontroller doesn't know whether it is input, whether it has to take input or it has to give output. Okay, so output is nothing but if you connect any relay module here. Relay is nothing but electronic switch. If you are doing a load control. So in that case, that D2 pin has served as an output. Okay, so to make that, you have to define it as an output mode. You have to put it in an output mode. So to do so, we have to use this pin mode command. Okay, so this is the syntax of that pin mode. So PIN and capital MODE. Okay, so this is the spelling. I have to follow the exact spelling. Okay, so it is a case sensitive. We have to follow exactly. And in the braces, we have to pass the parameters as pin comma mode. Okay, so pin is nothing but which pin you are using. In our case, I'm using D2, so I can name it as a 2, pin number 2, and the mode is nothing but output or input. So we can in mode we have three types of modes here: input or output or else input pull up. So okay, so leave it about input pull up. I will tell you when we get this topic. I will tell you, because if I explain now, you will get too confused. So only concentrate on these two things: input or output. Okay, so in our case, we are interfacing a sensor. Okay, so interface sensor, we are reading, we have the microcontroller has to read the data. So in that case, it has to define as an input mode. Okay, so then only it can read the data. And if you define it as output and if you read the data, it cannot read the data because you have already defined as an output. Okay, so the microcontroller will know the mode of the pin by using this command. Okay, and digital write. Okay, and this command will be used to write a value to the pin. Okay, so in our case we are not writing any value to D2, we are just reading. So in our case we have to use digital read pin. Okay, so digital read R should be capital, and in the braces we have to pass the pin number. That's it. Okay, if you use this command, it will read the all the data that has been sending from the sensor, whether it is high or low or else ones zeros like that. Okay, whenever you use this command to read the data from the pin. Okay, and then digital write. So digital write is pin comma value. Okay, so pin in this we have two parameters. First one is a pin and second one is a value. Okay, so if you write the pin number D3 or some other pins, and the value should be either 1 or 0 or else high or low. Okay, so microcontroller only communicates with a ones and zeros. Now we already know that machines cannot understand direct language. It can communicate through the ones and zeros only. Okay, so if you give 1, the pin will be set to 5 volts or else 3.3 volts level, or else if you write the value low, the pin will be set to value 0, means 0 volts. Okay, so this is how you can control the loads. Okay, so digital write, if you give pin number D5 to high, then it will write the 5 volts to that pin, where that 5 volts can be used as a controlling signal. Okay, that signal can be given to any of the modules like relay or else any LED. You can connect any LED and you can write the value to that LED to turn on and turn off. So this is how you have to utilize this function. Okay, so and then the fourth one is analog write. So this analog write function will be used to write some analog value. Okay, previously we have seen analog sensors. So we'll first move to analog write. So analog read. So yesterday we have seen LM35 sensor. So LM35 sensor, I have taken it as an analog sensor for reading temperature. Okay, so here this analog read function will read the analog data of that sensor by using ADC input. Okay, so in the Arduino we have seen A0 to A6, and in the ESP32 we have seen A0 to A8 ADC pins are there. So from that, if you just pass the pin number like A0, A1, A2 like that, it will read the analog data, and that analog data will be measured by processed by our microcontroller, which is coming from the sensor. Okay, if you just pass the pin number where you have connected the sensor. So in our case it is digital sensor. If you are using any other sensor like analog sensor, we'll try to use for a different we have so many tasks to complete. So in those tasks we'll try to use analog sensor as well, like a smoke sensor, gas sensor, or LDR sensor, as we have discussed yesterday. So we'll use one of them for the next classes. So if you just use this command, it will read the analog data and it will save it in a variable. And if you use analog write, so analog write is nothing but PWM value. Okay, so any motor driver which will control the motors. Okay, so this is will complete this task as well. So whatever the functions are there, will complete one task on that particular functions and sections. Okay, so here analog write will be used for controlling a motor driver. Okay, so motor driver means it will which will control the speed and direction of the motor, or else any other servo motor, stepper motor, normal DC motor, BLDC motor, like this.
Sir,
So
voice
this
is
kind of
not
motors,
audible.
is it now clear? Hello.
Yes, sir. Now it's audible, sir.
Fine. So yeah, so we are discussing what analog write value. So this command will be used to write PWM value to any of the drivers. Okay, so when you are implementing in real time in practical sessions, we'll get to clear understanding of the definitions of these pins. Just to keep it in mind. So analog write will write the PWM value. So pulse width modulation value means it will control the speed. Okay, so just just know about this definition. Will when you are using, you will get clarity. Okay, and the sixth one is delay. Okay, so delay is about it's like a stop. It will stop the loop. Okay, so when you're executing the your code in your microcontroller, if you need any delay for your microcontroller, so microcontroller has also some limited speed only. Okay, if you run the code at uh, very high speed, the micro can also there is a possibility microcontroller can also stuck. Okay, so to avoid those things, we need to use delay. Okay, so delay is nothing but it will stop the code for 1 second or else less than 1 second, like that. Okay, in we can give this delay in a milliseconds format. Okay, so this is how you can use this delay function and millis, and this is for measuring the time in milli seconds. Micros, this is for measuring the time in microseconds. So time is here, the time is nothing but uh, how much time the microcontroller has turned on and turned off. Okay, so to know about the time feedback, we have to use these commands. And this ninth one is serial begin, and this is nothing but this is for the debugging. Okay, so every microcontroller will have a debugging port. Okay, so in the debugging port, if you want to read print any data, okay, you have just read a DHC sensor data. Okay, we have just connected DHC sensor data. So, but we don't have any display to print the data. Okay, now in this case, if you want to print the data in any debugger, so that debugger is nothing but serial monitor. Okay, so in Arduino IDE, you'll be having a serial monitor here. Okay, so I will explain you about the features and options of this Arduino IDE software as well. What are the basic important things I will explain you. So this is the serial monitor. So here you can debug your microcontroller whether whatever the data it is reading. Okay. And to begin that serial monitor, you need some commands. So that command is nothing but serial.begin, serial.begin, and to print the data, serial.print, and to read the data by using your debugger, serial.read. Okay, and if you want to check any data from the serial, whether it is available or not. So yesterday we have discussed about UART communication. So if you want to check whether the UART has data input or not, you can use this command, serial data serial dot available. Okay, so this is how you utilize your defined functions in the Arduino program. So this is the this PDF will cover the most of the Arduino defined functions, because these functions don't require any libraries or any header files to use. Okay, so Arduino can easily identify these commands where because it's already defined in the Arduino compiler. Okay, if you want to use any other functions other than Arduino IDE, so in that case you have to use libraries, or else you have to use you have to create your own methods. So I will tell you how to do those things as well. Okay, so here, so this is about basic functions and the syntax in the Arduino IDE, and after this I will explain you about features of Arduino IDE. Okay, so this is how the format will looks like whenever you open a new file in Arduino IDE. So it will defaultly give you the two loops here. So one is a void setup and another one is while loop. Okay, these are the two main loops in the two main and Arduino defined loops that will defaultly comes up in the Arduino coding. Okay, so I will tell you the definitions of these loops. Okay, so here in the comments I have put your setup code here to run once and put your main code here to run repeatedly. Means, so here the setup code will runs only once at a time. Okay, so whenever you power on your microcontroller, so whenever you give power supply to the microcontroller, the first 10 seconds it will run the setup code, and after completing of this setup code, it will run the loop code, and it will keep on runs the loop code only. It will keep on executing loop code. Means it won't exit the loop code until and unless you are disconnect the power supply. Okay, if you disconnect the power supply, then only the power microcontroller will stop the running of this main loop code. Okay, so again if you put the supply again, and it will start from the setup, and after completing setup execution, you start the execution of while loop. Okay, so whatever the running code you have to put only these two loops. Okay, so if you want to run only once, you have to put in this loop, and you have to, if you want to run the code for every time the microcontroller is turned on, you have to put it in this loop, like sensing the data and sending the data to IoT platform. You have to keep that code in this loop section. And if you want to define any mode of the pin, like pin mode, like whether it is input or output, like that, those kind of functions you have to put in the setup section. Okay, I think you have got the point regarding these two loops. Okay, so other than these two loops, you can define other loops as well, like user defined methods. We'll call user defined method. Okay, so I will just tell you how to define a method. So void our method name. So I'm just thinking to put our my main code, like I'm reading a sensor data. Okay, sensor reading method, I will put in this method. Okay, so sensor reading code, all the code which I want to put in the loop code, I'll put in this method which is defined by me. Okay, and I will just call this method. Okay, so this is nothing but simplifying your code. Okay, so if you have any 500 lines of code, if you have 500 lines of code for your IoT platform sending and sensing data, so in that case, you can put total that 500 lines of code in this method, and you can just call that method in the loop section. So this is how you can simplify the method, simplify the code. So for now, you can see only this 4 to 5 lines of code. But in this main method, in this sensing method, you can put your total sensing code and sending code. So wherever, if you want to use this method, you can call this method just by using this format. Okay. So these are the main methods that we can include in the our Arduino IDE format syntax. Okay. And other than this, we'll be having one more section, that is so this is the second section. This is the third. This is the fourth one in our Arduino format, and this will be the first one. So in this first one, we have to include the header files, including header files. Okay, and then defining your pins, defining pins and variables. So these variables we can call as global variables. Okay, these are the global variables. And if you want to define a local variable, so those variables you can define in the setup, or else you can define in the loop section. Okay, so I think you guys know what is a local variable and what is global variable. So if you define the variable here in this section, you can utilize that variable wherever in the code. Okay, if you define the variable in loop section, you can utilize that function only to the loop section. Or else if you define the in the setup section, you can use that variable for the setup section only. So like this, the global variable will works. And defining pins is nothing but, so if you want to name a pin, okay, I'm using pin number D2 in our case. So if you want to name that pin, so I will just, so pin number here, D2 is an integer. So I will define it as a int. My DHT pin I will name. So if I call that name, just we can read the data by using that name itself. So I will just give the input as a digital pin number 2. So now if I want to read any sensor data from this pin number, I can use this pin name, DHT name. So this is a name that is defined by the user. Okay. So this is how you can define the pin numbers by using their name. Okay. So, and including libraries. So including libraries, we know that hash include. This is the format to include the library. So at the top of the code, you can include the library. So hash include less than and greater than symbol. In between this, you have to keep your library name. Okay. So in our case, we are including a library name, library that is for the DHT sensor. Okay. So for our DHT sensor, I'm using a library. Okay. So library is nothing but the library will be already written a code that will define the function that you have to read the data. Like I am reading DHT temperature data. So in that case, I have to use a library to read the temperature data, because that manufacturer designed the sensor to do so. Okay, so I will explain you clearly. After the explanation, you will get clear clarity. Okay, so to read the DHT sensor, to read DHT sensor data from ESP32, we need a library. That library name is nothing but dht.h. Okay, so I will tell you how to include a library as well. So before going, this is about total sections. Okay, dht.h. This is the total section. First section, library inclusion and defining variables and pins. And then in the second part is void setup. So to initialize the objects. Okay, so I will tell you what are the objects and pins. Okay, so here if you want to initialize the pins, like defining pin mode. Okay, so defining pin mode is nothing but I will define pin mode as, so pin mode, pin number, comma mode. Okay, so here I'm using pin number 2. So pin number 2 have given a name, DHT. I will name it as a DHT sensor here. So DHT sensor. Am I audible? Anyone confirm?
Audible,
so DHT
sir.
sensor. Yes, fine. So DHT sensor is a name that we can call. So because I have already defined pin number 2 as DHT sensor, so I can just simply use that name to define the mode. Okay. So pin mode, DHT sensor, comma, its mode. So which mode we have to use? In case of the sensor, anyone respond? Which mode I have to use here? Whether it is input or output or else other than these two. So as it is an interaction section, you people has to respond. Okay, so if you respond only, I can know whether you are getting the information or not. So previously we have seen this command in the PDF that is telling the definition, pin mode, pin number, comma mode. Okay, so I have written up to pin number. So I'm just asking about you guys regarding which mode I have to define to read the sensor data. Yes, I'm waiting for your response. So if I keep on going explaining these total topics, you won't get anything. If you interact with me only, you will get some knowledge out of this 5-day session.
Input, sir.
Input, very good. So in this input, we have to follow the syntax, that is capital letters. Okay, so input should be capital letters. Very good, someone responded. And pin mode, sensor number, I mean sensor name. Okay, and then comma mode. So in the mode, we have to define it as an input. Okay, so to read the data. So if you use small letters, it will give you the syntax error. Okay, so to define the mode, we should use capital letters only. We should indicate in a capital letters format. Okay, so pin mode, DHT sensor, and input. Okay, and if you want to use it as an output mode, in that case also you have to define it as an output with the capital letters. Okay, so in our case it is input. Okay, so that's it. And regarding this particular DHT sensor, we have to use a DHT sensor library. So in case of sensor library utilization, you have to follow the library commands. Okay, I will yes. So mute yourself. Someone is making noise, so please mute yourself. So this is the total code that have already written to read the data and send the data to one of the IoT platform. Okay, so now I've just explained you about the syntax and basic commands and basic options in the Arduino IDE as well. So I will let you know about some more options here. So here, this is the compilation button. So verify is nothing but whether your code is correct or not. Okay, so this will tell you whether the syntax is correct or not, whether it won't verify whether the output is correct or not. it will verify the syntax. Okay, so after the verification of syntax only, it will generate a binary file to upload it to your microcontroller. Okay, so if I click compilation here, it is showing that some errors are there. Okay, so DST library is not there because I have not included any library regarding this header file. Okay, so I will just comment that line. Okay, so this double forward slash is nothing but commented line. Okay, if you want to comment one line, you have to use this format, or if you want to comment whole paragraph, so in that case you have to use forward slash and then star, and then again in the ending line, so you have to again use star and forward slash. Okay, so this means this total paragraph has commented. So commented lines are nothing but it won't compile, or else it won't upload that lines of code into your microcontroller. So to avoid those things, you have to put this kind of commented indication. Okay, so in this case, so this is the total syntax, and after that this is the upload button. So this is the upload button. So when you select your microcontroller board and microcontroller port, it will upload the code to your microcontroller directly. Okay, so to upload, to select those options, you have to go to tools. Here this is the file. For the new sketch, you have to click on file and then new sketch, and then if you want to upload the code, you have to follow 2 steps. Okay, so I assume that your code is completed. So now upload, you have to go to tools and then select your board. So in my case, the board name is ESP32 Groover board. Okay, so ESP32 Groover kit all versions. So if you want to upload the code also, you have to follow the same steps. Okay, in case if you are uploading code to ESP32 board. Okay, so in the board, go to ESP32, and then in the ESP32 select your version of the board. So my version of board is ESP32 Groover kit all versions, and then select the port. Okay, board and port, these two are the important when you are uploading code. Okay, first one the board and the second one is port. So in which port you have connected the board. Okay, so I will just plug in the USB port into my PC, USB port. So it will hit the port. Okay, so here after selecting board, here you have to select the port as well. So in ports, it is showing some 5 number of ports. Okay, in this 5 number of ports, I don't know which port my board has connected. So to know whether which port the board has detected, you have to open device manager. Okay, so it is a Windows option, Windows settings. You can find it in the control panel. So if you open device manager here, just go into this ports option, expand this, and here you can see here some drivers are there: Silicon Labs, CP210X, USB to UART bridge, and CL over Bluetooth. So remaining all 4 options are Bluetooth drivers. Okay, and this one is our microcontroller port. Okay, to confirm that one, I will just plug this ESP32. I will just let you know whether it is showing the port or not. So now when I unplug the ESP32 board, the serial Silicon Lab CP210X driver has gone. So when I plug it again, so this is the method to find out your port. Okay, so now it has detected again CP210X USB to UART bridge. Okay, so now just select this port. So the port number of that is CP210X is common port 8. Okay, so I will select the common port 8 for this board. It is already selected. So I will just upload the code. So this is the steps to follow by the user to upload the code to your microcontroller. So the compilation has been going on. So after compilation, the code will be uploaded. Okay, so if you click upload button directly, it will compile the code and will upload the code. So if you just only click with this button, it will compile the code and it keeps like this. Okay, so if there is any errors, it will show the errors, or else if you don't have any errors, it will compiles and it will give you there are no errors. So these are the basic options to upload the code. And other than this, we'll be having some more options as well. So this is for downloading boards. This is a board manager. know. Okay, so this is a library manager, this is a boards manager, and if you want to download any external board, okay, so this software is particularly designed for only Arduino boards. And if you want to use other than Arduino boards like ESP32, ESP866, STM, STM32, Raspberry Pi Pico, these kind of boards, if you want to upload the code, you have to download that board from the boards manager. Okay, so in this boards manager, I will search for ESP32 here, whether we have or not. So here the ESP32 already installed in my software. Okay, if you are a beginner, if you are freshly installed this software, you have to go to boards manager and download the ESP32 for your Arduino software, and to download the libraries. So if you want to download libraries, you can search here for I'm using DHT sensor library. I will just search for the DHT sensor library. So I will just show you procedure on how to download the libraries. Okay, so among these, my sensor name is DHT sensor library. I have already installed. Okay, so here the remove option you can see, because I have already installed. And that's it. This is how you have to download the boards and download the libraries. Libraries are nothing but the resource files for your main code. Okay, so in our main code, if you want to read DHT sensor, you can download the DHT sensor library, and you have to connect the schematic like this, and you have to define the pin number in your library. Okay, so I'll just show you the main code here. So in the next class, I will explain you guys about how to create a cloud platform and how to create a database as well. Okay, so you should know about the database and servers as well, as you are dealing with the IoT platforms. Okay, in the next class, I will take full class regarding those topics so that you can get a clear clarity. So for now, just follow this syntax and the coding regarding this programming for completing this task: reading weather monitoring data, sending data to IoT platform. So here I have included some libraries here. You can see this is my code. So here, so this is the IoT monitoring code. So here I have included some libraries here. First of all, this is a one section. This is section 1, as we have discussed earlier. Okay. So this is the variable declaration and library inclusion section. And then this is the setup. So here you can define the pin modes, and you can define the whatever the object that needs to be initialized once, you can write here. And other than this, the final one is while loop. So in this loop, I have written all the code to read the data and send the data to Firebase. So we'll go through the line by line code of this part, and we'll try to understand these total things. Okay, so this is the coding part, and the first one is Wi-Fi.h. So as we know that ESP32 will comes up with the Wi-Fi chip. So that's why to deal with that chip, to communicate with that chip, I have included this Wi-Fi.h library. So from where I have downloaded this library means, if you go to library section, just search for Wi-Fi.h, you'll easily get some libraries. Among this, you have to download your required library. So I will just give you the links for your libraries in the protected text. Okay, so yesterday's class we have created a protected text NSIC IoT new website. So I have given you the link in the chat box as well in the yesterday's class. If you want to download and keep it, so save those library links, I will share them in the protected text. From there, you can copy and you can put it in your document, or else any soft copy. Okay, so this is the Wi-Fi.h library. I'll give you the link. This library is there for communicating between the ESP32 chip and our main code. Okay, so if you want to use Wi-Fi chip, you have to include this library. And if you want to use Firebase, okay, so Firebase is a one of the IoT platforms. So here we already decided to send data to sensor data to one of the IoT cloud. So that IoT cloud I have here taken as a Firebase. Okay, Firebase, I am sending data to Firebase database. So database is nothing but it's a storage that is provided in the cloud. So the cloud is nothing but where you can access the data by using internet. Okay, so that's it. And one second, I will That's it. So I will just give you a simple comparison between database and normal storage. So in yesterday's class, we have discussed about the hard disk and ROM and RAM memories. So in your computer, okay, I will just take a computer example. So if you're having any personal computer, PC, or else any laptop, if you have, so in that laptop, if you go to system info, it will give you the system info like 8 GB RAM, 128 GB, and or else 500 GB, 1 TB storage. So in that case, that storage indicates a local storage. Okay, so it indicates a local storage. Local storage, it's nothing but the hard disk. It's a hard disk. Okay, means it won't it can be accessed through your computer only. No one can access that hard disk through any other internet platform. Okay, so because it is only hosted in your system. Okay, so no one can access that hard disk. It's only for your personal purpose. And in case of cloud, okay, so cloud is a IoT cloud. Okay, so cloud is a database that can be accessed through your internet. Okay, so this in this cloud, some storage is there, same kind of local storage, some storage allocation is there. Data storage. So the difference you can understand, this is a local storage accessed by your personal computer, but this is a storage that is connected to internet and anyone can access through internet which who are having authorization. Okay, so that kind of storage I have created by using Firebase. Mute yourself, ma. Harish Babu, mute yourself. Okay, so this is the difference between a local storage and a database. Okay, so local storage can be accessed by the local user like personal computer, and this cloud storage can be accessed through the internet, anyone who are having internet access and as well as the database access. Okay, so here when I'm explaining about database access, it is nothing but authorization. Okay, so no one can use without any authorization because you have created that database for your purpose. Okay, so if you allow 10 members to use, only 10 members will have the authorization and they can only access the database to send the data and receive the data. So okay, so in our case I have created Firebase database. I will just show you the database here. So this is the database interface. Okay, so I will explain you in the next class about how to create this database and how to create the project for your database. Like here, I have created a project that is NSIC for my IoT monitoring and have created some tags here. Okay, so humidity and temperature. Okay, so it is sending some data to this tags. Okay, so if I upload the main code, I'll just show you the output and then we'll go through the total code so that you can get a clear understanding of the code. Okay, I'll just upload this code. Wait for the output whether it is sending live data or not. Okay, we can as well as we can check the data output in the serial monitor as well. Okay, so this is a serial monitor. So so the code is being uploaded. So after the compilation completion, it is uploading the code. Okay, you can see the progress here in the output tab. Okay, so the code is just uploaded. It is telling that the failed to read from DHT sensor. So the problem might be something have connected a pin number to different pin number. So we'll just show you the practical video as well, video feed as well. I will show you. So it is just started reading the data. Okay. So after completion of coding explanation, I will just show you the reading video feed as well regarding how I connected the DHT sensor with the ESP32. So it is measuring the real-time temperature and humidity value. The temperature currently it is 29 and 32 centigrade, I think. Okay, the humidity value is 85. So if you want to see this data in the Firebase database, like IoT platform, so you just open this IoT platform here. You can see it is sending the humidity data as a 81 percentage and temperature it is 35. Okay, so it is sending the live data of your sensor. Okay, so this is the output, and if you want to go through the coding part here, yes. Okay, so I'll just go to the coding part now, and after that again we'll see the output. Okay, so now we know that we have a ESP32, we have a DHT sensor, and we have a IoT platform. So reading the DHT part is a DHT sensor is a one part, and sending that data, read data to IoT platform is a second part. So we'll divide into two parts, and we'll see the how we are reading and how we are sending data. So for now, here I have included three libraries for the purpose of my task completion. Firebase ESP32 Firebase library for Firebase interactions, and this is for Wi-Fi communication, and this is for reading the DHT data from the sensor. Okay, so here I have connected pin number 5 to the DHT sensor, and have defined the type as DHT11. As we have types in the DHT types like DHT11, DHT22, 21, AM2305. These are the types in DHT family. Okay, so here my type is DHT11, and if you have DHT21, okay, so you can define DHT21. Okay, how to define correct type of your sensor. So in my case, it is DHT11. So based on the type, there might be some differences in ranges and accuracy. I have told you before as well. Okay, so after this, the most important thing is creating an object. Okay, so this line indicates creating object for the sensor. Okay, so here this is the object. Okay, so you have an object here in the real-time practical session also, in the practical implementation also, you have a sensor object. Okay, I will consider this as the object. So this object has to be created by using library name. Okay, because you are using library here, so to use that library, you have to define a object by using that library name. Okay, you can see capital DHT is here and here as well. So because I'm creating an object by using this library name, and the object name is DHT. Okay, this is a customizable name. So if you want to DHT, if you want to use it as a DHT1, I can change the name. Okay, so this is a user defined object by using the library, and in this object addresses you have to follow through. We have to pass through the two parameters. One is a pin number, one is a type. Okay, so DHT pin number I have defined as a 5, and type I have defined as a DHT11. Okay, so this is the format to define the pin number and types. Okay, so previously I have told you regarding how to define a pin number, int and DHT pin name and is equal to 5 and then semicolon. So this is the one of kind of definition of pin numbers and any variables. If you want to define the variable in other formats, okay, so this is just two types of methods to define your variable. So in my case, I'm using define as define method. Okay, this is one more method. Okay, so that's it, as define and name and then pin number with space and without any semicolon. Okay, we should not use any semicolon in case of as define method. Okay, so here as define DHT type, that type of passed in the object name. Okay, so this is the object for the sensor. So by using this DHT object, we can read the data, we can process the data, or else we can verify the data by using this object name only. Okay, and after that, defining the Okay, I will explain you these variables definition after the completion of reading of data. Okay, I will just complete the reading of sensor data. Okay, so here I have defined DHT pin as an input. Okay, so here we have to use either DHT.begin, either DHT input. Okay, so this pin mode command we should not use because we are using a library. Okay, so when you are using library, the total code regarding the pin mode definition will be there in the library itself. Okay, so because that's why we have to use the defined functions. Okay, so define to begin the object. So here we have declared the object, that is GST. So to begin or else to initialize the objects. So previously I have told you so objects we have to initialize in the setup code. Okay, so here what we are doing, we are initializing the objects for the sensor. Okay, so this is the object for the DHT sensor, DHT, and to begin the or to initialize the object, the command is DHT.begin. Okay, and to read the data. Okay, so to read the data, we don't have any bigger lines of code here. We'll just use our object name and read temperature command. And this read temperature command is not defined in the Arduino code. Okay, so if I comment this library name here and run the code, we'll get a error because I have not included any library for that command. Okay, it will show you the errors regarding whatever the commands you are using from that library. It will show the error. We'll just wait for the compilation. So here I have defined the variable float t. Okay, this t is nothing but temperature, and float is nothing but a data variable that is in decimal points. Okay, I think you guys know about the data variables: float, integer, string, character, and bytes, long int, long double, all these things. Or else I will explain you that part as well, including this coding part, along with this coding part. Okay, so meanwhile it is compiling, I will just give you the notes for variables here in the comment section. I will just share this code in the product text website which you have created in the yesterday's class. Okay, so float int long and then double and then so here float is nothing but small number of decimal numbers and small number of integer numbers and large number of integer numbers and large number of float numbers. Okay, so this is regarding numerical numbers. And then for characters, so this is char for only single character like A or B or C, like or else 1 or 2, like that. Okay, I'll give you the examples in the 2, 3 or A, B, C, etc. Okay, these are the examples for this. And for float, 23.22 or else 44.45. So okay, this will comes under examples for float. And integers is nothing but 1, 22, 23, 45, like that. It doesn't include any decimal points. Okay, so these are the examples for this data variables. And in case of long, the same examples comes but with a large storage allocation. And in case of double, it's the same float. I'll just indicate as a long float, long integer. That's it. So this is character and this is string. So for string, we can have examples of your name or any combination of characters we can call string, NSIC or any IoT. this kind of combination of letters will be called as a string. I think most of you guys already know, but why I'm telling is you can someone who is not introduced to these things he will also know. Okay. So this is about data variables, and the code also compiled, and it is showing the error that is DHT does not name a type. Okay, so it is showing the first error where yeah, here it is showing a error. DHT name does not name a type because I have not included a library here. Okay, so that's the purpose of library, and it will show you the errors regarding DHT temperature and DHT read humidity. Okay. Why it is showing errors regarding these lines of code is you have not included library. Okay, because this read temperature command and this DHT is not a part of Arduino IDE defaultly. Okay, so for using these kind of commands which will not include in the Arduino defined functions. Okay, so previously I have explained you about Arduino defined functions, pin mode, digital write, digital read. All these functions doesn't require any library to use. Okay, so in case if you want to use other than these commands, you have to use the library. Okay, in case of DHT sensor, you have to use this library, and in case of Wi-Fi, you have to use Wi-Fi, and in case of Firebase, you have to use Firebase. So that's it about reading the code, reading the data. Okay, up to these two lines, you can see float t is equal to dht dot read temperature. So when you use this command, the internal code will be differently written in the library. Okay, it's already written in the library, the part which is used for reading the code, reading the data. Okay, and regarding humidity, it is DHT. DHT is nothing but our object name. So if you have two DHT sensors, in that case, what you will do, we'll create a one more object. So I'll copy this line. Okay, I'll copy this line like this, and I'll paste it, and I will name it as a DHT pin DHT2. Okay, in this case, it is a object 2, and if you have you have to define the pin number and a type in this format. So I will connect the pin number 6 to that sensor, and that type is same DHT11. Okay, so that's how you have to define the variables in case of more than one object. Okay, so this is how object works. Okay, in case of servo motor, in case of any objects like uh, Firebase, also you can use more than one objects by using library name. Okay, so this is how reading the data. So now we have to send the data to our Firebase. Okay, so we have just read the data, but we are not sending the data to Firebase. So to send the data to our Firebase, we have completed reading the data and printing the data in the serial debugger. We have printed the data in the serial monitor. We have seen. Okay, that data we have to send that to Firebase. So to do so, we have to. Okay, so I just remove the error. I have uncommented this line. The error has gone. I will compile it again. So meanwhile, I will explain you the code that required for sending the data to IoT platform. So before sending the data to IoT platform or any database, we need internet connectivity. So without internet connectivity to any microcontroller, it won't send any data to your IoT platform or any database. Okay, so firstly, we need to concentrate on connecting our ESP32 chip with the our Wi-Fi network, because through Wi-Fi only it can get the internet. Okay, so to get connected to internet, this ESP32 board, we have to include a library. We have seen that Wi-Fi.h library we have to use, and after including library, we have to initialize that module. Okay, so I have just created a method. Okay, so this is the external method, void connected to Wi-Fi. So previously I have told you we can use external methods. Okay, so this is the external method, or else user defined method. User defined method. So this is a user defined method that we are going to use for connecting Wi-Fi. Okay, so here I have written whatever the code is required for connecting to internet, and I have called that method in the setup. So why setup? Okay, we know that setup will run the code for only once at a time. Okay, once in the execution. Okay, and it won't run again and again. Okay, so that's why here we can only connect to Wi-Fi only once. It doesn't need to connect Wi-Fi again and again. Okay, so if we put this line of this method in the main loop, the what will happens, microcontroller will connect it to Wi-Fi again and again, even though it is already connected to Wi-Fi. So that doesn't mean anything. Okay, that doesn't make any sense. Okay, so that's why we need to use this command in the setup section. Okay, so this means we have connected to Wi-Fi only once, and after that the code is started to execute in the loop section. So it will execute whatever in the loop section using defined functions. Okay, so we'll see what are the commands in the method here. Wi-Fi.begin. Okay, so in this Wi-Fi.begin we have two parameters, network and password. So network is nothing but the your network name. Okay, and then password. Okay, so like if you want to connect to your friend's Wi-Fi, you will just know your Wi-Fi, your friend's Wi-Fi name, I mean hotspot name and hotspot password. Okay, so we'll just connect, we'll just click on that Wi-Fi network name and we'll just enter the password and we'll connect to hotspot and we'll access the internet. So in the same way, ESP32 also needs Wi-Fi name and password. Okay, so here for doing so, I have defined already the variables required for connecting to network. So here in my case, the hotspot name is Raspberry and password is 12345678 9. Okay, so I have just passed these parameters in this Wi-Fi.begin command. So just concentrate on this command, Wi-Fi.begin. So in case if you want to use connect this ESP32 to any network, you just use this Wi-Fi.begin command and pass the Wi-Fi name and password as a string here. Okay, so I have indicated in double quotes, means it is a string. Okay, so that's it. And after this Wi-Fi.begin command execution, it will connect to Wi-Fi, and to know the status whether it is connected to Wi-Fi or not, I'm just using Wi-Fi.status command. Okay, so in serial I'm printing a feedback. Okay, serial.println connecting to Wi-Fi. So connecting to Wi-Fi will be printed on the serial monitor whenever we start the device. Okay, I'll just show you how it happens. I've just plugged in the ESP32 board. So whenever I plug in, so this method is called in the setup, means the code will be executed at once. Okay, so the connecting to Wi-Fi, it has printed in the serial monitor. Okay, connecting to Wi-Fi means to give the feedback regarding what where the code is executing. Just printed a line. Okay, and after this I'm using a while loop here. Okay, so while loop is for getting the feedback whether the Wi-Fi is connected or not. Okay, so whenever the Wi-Fi status is not connected, Wi-Fi.status and not equal to symbol and WL connected. Okay, so this line of code means the whenever the Wi-Fi status is not connected, this while loop will execute. Okay, so what are the lines of code in the while loop, we'll see. Okay, so this is a highlight indication of this while loop. For flower bracket will indicate the starting flower bracket and ending flower bracket of your while loop. Okay, so whenever the Wi-Fi is not connected, it will print the dots in the serial monitor and as well as the failed. Okay, if Wi-Fi status is not connected, it will print failed. If it is connected, it will print the connected. Okay, and after that, you will print the IP address of your network as well. Okay. So to print IP address, Wi-Fi.local IP, this is the command. And then, so this is how your ESP32 will connect to Wi-Fi network. And now we are completed with connecting the ESP32 chip to Wi-Fi network. So now what we need to do, we need to send the data to IoT platform. So we have read the data, we have connected ESP32 to Wi-Fi, and we need to send the data to Firebase. Okay. So now we'll move on to our Firebase part. So I will move on to loop section here. So these two commands we have seen earlier, and this is a command for checking whether you are getting correct data or not. So is none is a command that will check whether the temperature data is none or not. Okay. So if temperature is none, it will print the fail to read the data from DHT sensor. So previously you have seen that this command already printed in the serial monitor, because when it is came, the error came, have not connected sensor to the ESP32. So whenever the data is none, it will print the like this. So if this is for just a feedback, like a debugging method. So after this, after reading the data, we can just print the data in serial monitor. So to print the data in the serial monitor, serial.print humidity, and then the humidity variable. Okay, humidity variable is nothing but H. I'm saving the humidity data in the H variable. So I just call that variable. Okay, so now what happens? Humidity, it will print the humidity string in the serial monitor, and after that it will print the humidity value, and after that it will print the temperature string in the serial monitor, and then after T variable. So T variable is nothing but temperature variable. In the T variable we are saying temperature data in centigrade, and then I'm printing a centigrade symbol for indication. Okay, so for temperature, for humidity I'm printing percentage symbol. For temperature I'm printing centigrade symbol. Okay, so after this, the two main important functions. So these are the two commands that we need to use for sending the data to our Firebase. Okay, so Firebase IoT platform. So that to sending the data to Firebase, we need to use these commands: Firebase dot set float and Firebase dot set float. So two similar commands to send it two different data. Okay, this is for sending data to tag name humidity. This is a tag name temperature and variable name T. Tag name humidity, variable name H. So this is the format. Okay, so this is the format to send the data to our Firebase IoT platform. And if you are using any different IoT platform like ThinkSpeak, Blink IoT, or else any other platforms like Raspbian, in that case, you need to have different commands according to their Firebase structure. I mean database structure. Okay, so for ThinkSpeak, we can have a different commands, customized commands. Those commands will be provided by the manufacturer or else developer. Okay, so the developer, whenever they develop a platform, IoT platform, they will give you the a data sheet manual where the developer, means us, can go through that data sheet and we can use those commands. Okay, this firebase.setFloat command is not generated by me. Okay, it is already defined in the data sheet that I have customizedly using for this IoT platform communication. Okay, so firebase.setFloat, and this is the syntax to send the data to Firebase. So here the Firebase is nothing but the object. Okay, so here our library name is ESP32 Firebase. Using that library name, we have to create an object. So we'll see where I have created the object here. So here Firebase. Okay, so I have created object here, and as well as to communicate, to initialize the communication, we need to use one more command, that is, so here we can see, yeah, this, 1 second. So here we can see the command, that is Firebase data URL. Okay, so here the data URL is nothing but this URL of your database. Okay, so whatever the database, if you I will tell you example. So if you get your semester results, okay, to get those results, you have to go through a link. Okay, so that link is nothing but, you can call it as a URL. Okay, so in the same way, if you want to access the data that is sending by this ESP32, or else to send that data, you have to provide the link. Without link, it cannot send the data. Okay, so that link is nothing but this HTTPS colon and NSIC something is there. Okay, so this link I have got from the Firebase. I will tell you how I got. So here you can see the database URL. Okay, I just copy from here and paste it in the code. And one more token that we need to use for Firebase communication is API key. Okay, so this is the API key. So API key means only authorized, if you want to send the data and read the data by only authorized persons, you will generate a API key. Okay, I will tell you how to generate URL and how to generate API key in the next class. For now, just listen. And this is about the API key. So it's like a password. Okay, so for your smartphone, you'll keep a password in the same way. It is a password for your database. Okay, so I have created password for the database by using this API key. Okay, so if I provide these two credentials regarding Firebase database, the ESP32 will start the communication by using internet access to send the data and receive the data. So in our case, we are just sending the data by using firebase.setFloat and firebase.setFloat temperature and humidity. Okay, so this is the total code. There is no other code is there. So okay, so this is our totally 100 lines of code is there, and it is less than 100 lines. It is totally 50 lines if you compress. Okay, so this is about the coding part. Okay, so as we have already seen the output, I'll just start to show the video feed in the from my mobile phone, and meanwhile you can ask for the doubts, okay, regarding coding part, regarding software part, regarding hardware part. If you have any doubts, let me know. Meanwhile, I will show the video feed output. Okay, and we'll see the video output, and then we'll end the session for today, and for tomorrow we'll have a new session. I'll just plug in the boot to PC, and then I will upload the code. So to upload, I have to click on this button. So if anyone having doubts, please respond and clear out doubts in the class itself. Unmute yourself and express your doubts. Okay, feel free to clarify your doubts, because we have only 4 days of time to learn this IoT platform clearly. Okay, if you don't ask doubts, you can. It's hard to find out your clarifications in outside these classes. So this is a video feed. I'll just pin my account to get the video feed here. So anyone confirm me whether you are getting the video feed of the kit or not? So here I have connected ESP32 as I have shown you in the schematic. In the same way, I have connected DHT sensor with ESP32. So all of you can see or not? Anyone confirm?
It's not clear, sir.
It's not clear. Okay, so in the video classes, I think it's somewhat not clear because of the internet access. So no problem. So I will share you the video of the execution as well. After the class, I will share you the video in the WhatsApp groups. So please go through those videos and PDFs, whatever I will share you as resources. Okay, so for now, just see the kit, and I will share you the clear video of the practical session after the class. Okay, so this is how I have connected. So I have connected 3.3 volts ground and a signal pin. Total of 3 pins have connected to read the DHT sensor data with ESP32, and I have powered the ESP32 through USB cable through my PC. Okay, so this is the hardware connections, and this is the results of our key, how it is sending the data to database. Okay, so here we can see the temperature and humidity. It is sending as a 40 and 47 something is there. Okay, I think the temperature is not perfect value. It is giving some other wrong value. It is giving good humidity value, but it's not giving temperature. So we have to just re-upload the code. Okay. So this is the kit video. So I think I have told you that meanwhile, if you have any doubts, you have to unmute and you have to clear your doubts. I have told you. So if you don't have any doubts, means the class is very clear to all of you. No one has any doubts? Raise your hand. Nearly 30 participants are there in this class. So please respond and interact with me regarding today's class. You can give me the feedback also. If you give feedback, if you give feedback, then I can know whether I need to give more information regarding this topic or not. I will get to know. So this is the end of the video session. We'll just see the output and we'll close the session again. We'll just see the video results again. I think the sensor has some issue. That's why it is giving values differently. That is 35 and 49. So after the doubts clarification session, we can end this class for today. So if you don't have any doubts, please let me know. If you don't have any doubts also, you can let me know. Sir, we have understood totally. You should have doubts because I have completed total software, hardware, and coding part in one class. That is 1.5 hour class. It is difficult to understand clearly, but in next classes also there's a similar kind of topics will be there, so you will get to understand clearly at that time.
Dear participants, if you have any doubt, you can raise it in chat box also in question answer session. If you don't have any doubt, we can wind up the session for the day. Just thank you participants for joining these sessions and have a great day.
Yes, in the next yes. Thank you.
Prabhu, are you there?